R&D. We had to innovate across all layers of the stack. We have the Flower isolation model, which isolates the entire system into containers for Superlink, for Supernode, for SuperExec, for the app executors, full run, full federation isolation, isolated VMs. We have auditable communication. You can track the communication down to a single gradient. It has large weight streaming, of course, and built-in auto deduplication. It has best-in-class Kubernetes support and Docker, native Kubernetes support, optimized, hardened, security-scanned Docker containers, official Helm charts, decentralized governance and trust, which is key to deploying large federations. Later today, you're going to hear about the world's first heterogeneous confidential compute. I'm not going to say more. I don't want to take the surprise away. Flower Hub integration with verified apps. You're going to hear a lot more about this later today. Verified apps is a key feature and a very unique new approach to app verification and to scaling federation. And just to summarize, I think SuperGrid is really advancing the state of the art. It's a platform for the era of collaboration, and it leapfrogs everything you've seen in collaborative AI before. This is something we can do at Flower Labs because we have this strong advantage of vertical integration. We are doing the research, we build apps, we build the framework, we integrate the framework with other systems, we build the platform, we operate the platform, we provide support to users, and we help users build their solution end to end. And to quote one of our amazing early users, Dr. Nicholas Conce from DocPort, SuperGrid has become their standard for collaborative research in primary care. And we are super happy to support that because I think it's a really crucial project to do that. Thank you. You're welcome. The best news is SuperGrid is available today. You can just go to flower.ai and sign up. Now, for everyone who registered for Flower Summit, if you sign up, we have a little goodie for you. If you sign up within the next 48 hours, you get 3x the welcome credit. Let's go to building block number 2. I still see some phones. Okay, it's just flower.ai. It's very easy. Okay, let's take a look at the second building block, our frontier training stack. If you joined us for the last few years, you've seen that we have years of research in decentralized LLM training. We invented a couple of key techniques, for example, decoupled embeddings for pre-training. And earlier today, Nick announced our first state-of-the-art LLM. It's called Lizzie 7B, and it's Flower's first state-of-the-art LLM. We wanted to produce a very special model. We wanted it to generalize well, but we also wanted it to do really well on a particular task, something that really Lizzie is uniquely good at. And so we built Lizzie to be uniquely British. We built Lizzie for the UK, as they might suggest. I think the interesting part about this is that once you chat to it and once you see it, you see that it's uniquely good at certain things. And you might wonder, these optimizations, do they maybe jeopardize the generalization you want to have in an LLM? And I'm happy to announce that Lizzie is actually European state-of-the-art for its size. So comparable to other models like Mistral 8B, Apertus 8B, the Swiss model, or something like a Euro LLM 9B, Lizzie is on par or better than these models. So it generalizes really well across a wide range of tasks. Lizzie 7B is available on Hugging Face, so you can chat with Lizzie and you can integrate it into your apps. Lizzie 7B is built on SuperGrid Frontier. SuperGrid Frontier is our training pipeline. It enabled us to, it does certain things really well that you need to do in decentralized training. So for example, last year we announced that we were able to reduce communications by up to a factor of 1000x. And we are working with partners to optimize and to further evolve our SuperGrid Frontier training pipeline. For example, we're working with the Department of Energy, we're working with Sandia National Labs, and the goal here is to perform a decentralized training of a 70 billion parameter LLM geographically distributed across the 3 big national labs. So that's SuperGrid Frontier. It's our Flowers state-of-the-art LLM training pipeline. If you want to work with us on LLM training, you can apply for the Flower Pilot program and make sure to select the SuperGrid Frontier track. The last building block is a collaborative AI agent. And I want to start with just the first announcement and maybe the obvious one. AI agents are coming to SuperGrid. And because AI agents can take advantage of SuperGrid, this will unlock new capabilities and I think a new generation of AI agents. Before we go there, I just want to come back to this picture real quick and say, if we look at this from the perspective of agentic AI, we see that all of the data on the web, most agents have access to that. Most agents can use a search tool and then fetch certain context and use that to come up with better answers. But really the data on the right-hand side is, again, missing context for these agents, and maybe the insight is exactly in that data. Maybe your organization is already very advanced in adopting AI agents and has enabled your agent to maybe leverage the data in your organization. But then what happens if the answer that the agent is looking for is actually not in that partition, but maybe the answer is over here? Your agent doesn't have access to it, for good reasons actually. The answer might be in someone else's data set. And so I think if we look at what is needed to build an agent, what are the capabilities fundamentally that agents need, you can take a look, you can sort of categorize it in 3 categories. The first category is your agent needs to be able to retrieve data, it needs to query the web or query a private data source. It needs to be able to reason on the information it got, on the prompt and that data. And then it needs to be able to take actions. But I think if we take an analogy, an agent that works like that is a little bit like a single person sitting alone in a room. This is not how history is made. History is made by groups of people collaborating. Everyone does their own work, and then you work with others to come to better conclusions. So the question is, what's missing? And I think what's really missing here is collaboration. You want these agents to be able to collaborate with one another. This requires messages. Agents need to be able to send messages. One agent needs to message another agent and get the replies from these other agents. But actually, you need a lot more than that. You don't just want your agent to randomly send messages without you being in control. You need a full governance system that you can use to control and configure what this agent is able to do. So I think you don't need just messages. What actually you need for collaboration is SuperGrid. And so we built we want to show a very early prototype of something we built. We call this Project Kaya. And Project Kaya is a collaborative AI agent. And so I'm going to show a quick demo. So I'm going to start with something very simple. And it's because Project Kaya is running on SuperGrid, I can connect data to it. And I can allow the agent to use the data I've connected. So let me try to ask it what's on the internal Flower Labs roadmap. Let's see. This is really a tiny hello world to show how it can access private data. So we can see the results that it's checking. We can follow the full progress. It's reading some Notion pages. And it's telling us what's on the roadmap. So for example, for Flower 130, we can see that the Superlink will get an agent runtime. Okay. The real power with agents comes from giving them access to SuperGrid and giving them access to your federations that you have on SuperGrid. So let's try, actually let me start that from scratch. Let's try another prompt here. So this is a federation called Frontier Health, and in that federation we set up a number of hospitals, each hospital with its unique data set, and these are globally distributed hospitals. Now let's trigger that query. It's something about the data in preventative care. And what you can see here is that the agent actually is aware of the federation. The agent goes out. The agent knows what's connected to the federation. And then in those supernodes that are connected to the federation, there's other agents running there. Of course, because the supernode is under the full control of those organizations can fully configure what the agent is allowed to do, which models it can use, whether the models need to be self-hosted or whether it's acceptable to use a cloud model. And you can see how it makes progress. All of the hospitals that are connected are now finished. I'm going to just expand this one more time. You can see the hospitals that are online. You can see the ones that are offline. You can see they're finished. You can exactly see the communication events that happened. And then, of course, the results we get from these hospitals are all locally governed. So whoever is in control of the supernode can decide what the supernode is allowed to reply or not. You can follow the full trajectory here, and then in the end, you get the results. So that's a sneak peek at Project Kaya, and it's coming in 2026. If you want to work with us on the future of agentic AI, collaborative agentic AI, apply for the Flower Pilot program and make sure to select the SuperGrid agent track. So I think it's obvious why we believe that the next frontier is collaboration. We go from isolated silos to collaborative networks. There's huge historic precedents for that, and once you see the opportunity, you just can't unsee it. And so at Flower Labs, we're building exactly that stack. And today we introduced Flower SuperGrid as the next-gen AI platform that powers the collaborative AI era. We introduced SuperLizzy 7B and SuperGrid Frontier, our Frontier state-of-the-art training pipeline. And we introduced Flower Agents and Project Kaya, a collaborative AI agent that's running on SuperGrid. Thank you.
Okay, so thank you, Daniel. That was an incredible keynote. So much to think about. What we're going to do right now is take an 8-minute break. You can relax. We're going to come back and have an incredible fireside chat. So please come back in 8 minutes.
Hey everyone, welcome back to the live stream. We just heard Daniel give his keynote with the 3 highlights that we are announcing today here at Flower Labs. The one which is Flower SuperGrid is live for everyone to jump on and use. There's also Flower Agents and also the announcement of Lizzy 7B, our first frontier model that is built for open use based on the British data sets. So we are going to have a very short break only. This will be a very short, roughly 7-minute break before our next panel, and the next panel we'll start off with a very interesting fireside chat with John Dvorak from Red Hat. We have also a pretty nicely lined, nice lineup of speakers as well. So after the fireside chat, we have a panel that talks about sovereign AI and arrival of European neolabs, and then also talking about how federated training of a 70B LM can be achieved. Then Patrick Foley from Flower Labs will wrap up the session to talk about Flower Convolutional Compute. Okay, so in a very short time that we have left, we have our very own Daniel Nata from Flower Labs, who's going to give us a very quick talk about what he's been working on. So come on in, Daniel Nata, jump on in. And I will guide you, if you can stand a bit closer to the table over here. That's great. Yeah, I know Daniel Nata, we've worked together for a couple of years now, 2 years or so, and you've worked on a lot of things. So more recently, and for those who don't know you, can you introduce yourself and also what you do here?
Yeah, hi everyone, I'm Daniel Nata. I'm a machine learning engineer in Flower Labs. Been working since 2 years. I've been working usually for on-device LLM or on-device machine learning, but now I'm working for Project Kaya, the collaborative AI agent.
Nice, very nice. I heard that Daniel just mentioned, literally hot out of the press, maybe 15 minutes ago, about what's it about. Do you want to give a quick summary to the live stream audience again about what is it about?
Yeah, so the first time when we want to create this Project Kaya is want to create a really good AI agent platform, and then when we try to create these things, we feel like, oh, everything inside agentic AI is actually orchestration, and we already have this orchestration in SuperGrid. And along with this orchestration and agent, usually in the news that there is a leak when people do OpenClaw, there's hijacking in this kind of AI agents. And then we say, okay, if SuperGrid has a really strong isolation model, it would allow us to create a collaborative AI agent with the best performance, but have the best governance and also isolation model. Yeah.
I think it's pretty cool. I agree. When the idea was floated some time ago now about this internal project, before it materializes at Kaya, I can see a lot of interesting ways to use it, and it's very different to how typical agents are out there right now being used. So, do you have any use case personally that you have thought about that could be interesting for Kaya?
Yeah, so I think most of these use cases will be presented by my colleague Charles. He will have a talk later in this afternoon.
Yeah.
But one thing that is really, I feel it really good is maybe a federation management. We can allow agents to manage the federation inside the SuperGrid. So that would allow us, for example, the agent would find similar cohorts and select particular clients, and then we can utilize these agents to build, to make better training process.
Right. So essentially is not just federated AI in a conventional typical sense, but combining it with the power of agentic tooling to allow some semi-automated way of configuring the participating clients.
Yes.
Yeah. I think it's pretty cool. Yeah. I might be biased, but yeah, it's great. So I think we're going to wrap it up. We have another person jumping on a live stream as well, and we have a few minutes left. Thanks, Daniel Nata, for jumping on, and I'll see you in a bit. Okay.
See you.
Yeah. Awesome. We have someone else to jump on a live stream in the remaining time that we have. Yep. So come on in. We have about 2 minutes. We have another 2 minutes. Yeah, come on. Step on in. Yeah, step on in closer to the... Thanks. We're speaking over there. Okay. No worries. Yeah. I think we briefly met as well at the breakfast this morning.
That's right. Yeah.
Correct. Yeah. For those of you who don't know yourself and also what you do, can you quickly introduce yourself?
I'm Harish Karthikeyan. I'm a senior research scientist at JP Morgan AI Research and also affiliated with JP Morgan AlgoCrypt Center of Excellence, where the idea is that we are one-stop shop for cryptographic expertise within the firm if anyone wants it. And in this context, I've been working a lot with regards to privacy-preserving federated learning, bringing secure aggregation to the literature of federated learning, and making it work. And so, I mean, my talk was also, in a way, trying to encapsulate what secure aggregation is, because it can be such a daunting term, if you will, where people don't know what it is, they just like to use it. And so I wanted to make sure that people understand that it's as much of a black box of a black magic it can be. It's actually pretty much fancy terms for very straight mathematics. That's sort of been my focus, if you will.
Yeah, I like the way you phrase it. I think it's also an important mindset to think about as well. You shouldn't be thrown off the guard by what you mean by secure aggregation.
Yeah.
Just being able to do computations in a very secure way, I think that's also one way to think about it. That's great. For your work, I believe you gave a talk as well, right, this morning, and also I think it would be very interesting to speak with a lot of other users. I'll be curious to know what your experience is later on when you speak with other users, the appetite for using such types of computations later on as well.
Yeah, I mean, I think I'm seeing a lot of use cases from the healthcare world where I think privacy is definitely something that's paramount. And I mean, I think early adopters would be the healthcare world because they can tolerate a little bit of delay, if you will. Whereas in financial world, you can't afford the friction between privacy with and without privacy. I think that might be the bottleneck, yeah.
Nice. Thanks for sharing that. I never really thought about it that way, but perfect. I think we have about a couple of seconds left before we are going to kickstart the next session. Thanks again for jumping.
Thank you so much. Yeah, thank you.
I'll speak to you in a couple of minutes.
Sounds good. Yeah, thank you.
All right, see you.
Yeah.
Bye. Okay. All right. So, thanks everyone for staying on the live stream. We are about to start the next session right now with the Fireside Chat with John Dvorak. And yes, if any questions, feel free to pop them in our public Slack, and we'll see you in a bit. Thanks.
Okay, everyone, let's get settled again. Okay, so our next session, we have a real treat here. We're going to have a nice fireside chat with John Dvorak. He is CTO for public sector in Red Hat. Red Hat is obviously a big proponent of open source, works with a lot of important institutions, keeps the lights on quite literally for many, many settings. And Flower and Red Hat have been working together quite intensely now for quite a while. We noticed that John was in town and he could stop by to our event for a few hours. And so it was a perfect opportunity to chat with him about how he sees AI evolving, how he sees things evolving in the public sector, and also how does this sort of collaborative, decentralized, federated kind of dimension to technology sort of play into that. So John, I was looking through your background, a long history in different organizations, FBI, NIH, and now Red Hat. And so in the direction of mission-critical systems, what's your view of how AI has evolved in terms of going from largely very centralized systems to more distributed, federated types of AI?
Yeah, well, first of all, thanks for having me. This is great. I'm glad this worked out. Wasn't originally going to be here. Tony's going to be talking later from our team in a couple of hours, and it was great that we got a diversion into London for a couple of days. So a big part of my career has been in large data systems and AI and largely predictive AI over the pre 5 years ago when we started getting into Gen AI and more probabilistic models. And at that time, a lot of course, what we were doing is building huge data lakes and bringing all the data together and doing exploitation of systems based on just larger and larger amounts of data. Certainly we were working in the area of federated learning, but in a different way than we do today. But the idea of there's certain data you can't mix within intelligence or law enforcement systems, and we still had to keep them where they were. But it was very painful. So I see a lot of great changes in the last several years where the incentives are right, the technology is right, the governance has kind of pushed us in a way where we're seeing more around federated learning. We're seeing better scaling solutions, better solutions closer to the edge, which is a lot where my customers are really focused on, particularly in the defense space. What can we do more outside of data centers, more what they say downrange of data centers. So that's to me it's a very exciting time. So it's certainly at Red Hat, like a lot of companies out there, we've had a huge shift over the last couple of years in terms of how we think about AI, and we've gone from, just like with our products, we've gone from AI being a part of what we're doing to being like the major force of what we're doing. In addition to that, our whole development cycle around AI has changed. So we've gone, as many companies are dealing with right now, where it's the AI age, we're rethinking how we even do engineering internal to the company. So lots of things coming together, very interesting. And we've talked about AI for like 30 years of my career, but like finally we're doing it, I think, in a way that we always envisioned when we were kids. So
interesting.
Yeah.
One of the big topics that's come up today in conversation has been the issue of sovereignty. Flower released its first LLM that offers SOTA performance for the UK. There's a lot of discussions about sovereignty in general. And so I was wondering about your views on that topic. It's a very loaded term, means different things to different people. And I think one of the questions that comes to my mind would be, what for you are the biggest misconceptions as that topic pertains to data sovereignty in particular, and in this AI era?
Oh yeah, sure. Lots of these 2 weeks that I'm here in Europe, visiting multiple government agencies in multiple countries in the EU and the UK, and digital sovereignty is probably the first, second, and third most discussed topic. So this is really important. Certainly, like the misconceptions, I'll say there's several. You mentioned one right off the bat, is like there's not a common definition. It is not a binary problem. It is not you are either sovereign or you're not sovereign. And a lot of things, as you know, like when you start to talk to decision makers about where the line is, it's just like with cybersecurity we had for 20-some years, like how cybersecurity you want to be, and then you start to look at the cost and you start looking at the impact of business, and they're saying like, a little bit less because it's impacting my business. So that's an ever-moving target. Another thing is data residency is not data sovereignty. That was one of the early misconceptions we had. I think everyone here knows the story there, but there's plenty of cloud providers that will provide you service within country, and you'll have data within country. That does not mean that data is sovereign. It does not mean you're going to get around things like the U.S. Cloud Act, which affects U.S. providers. So you have to be thinking about solutions that are you have to hold the keys to your encryption. I mean, that's when it comes down to, like, at what point who owns the secrets, who has the ability to manage that, to look at and exploit your data. So that becomes a big topic with these countries that are building their own environments. So, and it's also you can go the crazy way of just saying, well, I want to build all the data within my country. I want to build a sovereign solution. Have data residency, potentially not thinking about the long-term impacts of long-term management of that environment. We have certain countries like further east in Europe that are very worried about if certain things happen, are they able to reconstitute their data system? These are kind of problems I'm having to deal with. Are they able to reconstitute their government somewhere else? Can you have a sovereign solution outside your country? So this is where the data residency comes up. It's like, yes, you can build solutions outside of outside of data residency that meet the concepts of data sovereignty. We have to think about, again, where you're encrypting, who holds the keys, that sort of thing. So it's a complex problem. And you have to get through those conversations with every customer you talk to. They've heard something, they've read something, and then they think that's sovereignty, and so there's a lot more to it.
If you think about where AI is going, do you think we're going to see more edge first or networked AI first rather than centralized systems that seem to really dominate currently?
Yeah, I think no surprise to that question is, well, first of all, I'll say, what is edge? So edge means a lot of things, and many edges, and downrange of a data center, there's many places where lots of data is collected, and as we know, like, you know, we saw the numbers up here. There's a lot of data collected, much of which is junk, but there's a lot of data collected at various places within your operational purview. And as we say, we got to move AI to the data. I mean, so that's the answer. Is that if the data center when the data center makes sense, the data center makes sense when it's further downrange, and we have to build solutions where we have to understand data closer to the source. And we only want to bring back the important telemetry from that data. We're going to put AI there, and that's going to be where we run. So what's changed now, and we've always had that concept. What's changed now is downrange. On the edge, we have more capable. We have better technology. We have better models. Quantized models that can run on smaller devices. We have TPMs to allow us some kind of secure control over those devices. So I think the answer is all the things. We're going to see more, of course, because more and more data is being generated at the edge, and bringing that back is expensive. And again, like, it's a waste of time because 99% of that data is garbage. I don't need that back in my data center.
Right. I mean, I guess this issue of edge and networked in relation to centralized brings up an interesting type of technology that Flower's been investigating and using for a long time now, namely federated learning. Yep. What are your views on federated learning in the sense of it's had ebbs and flows? It's massively used inside companies like Google still, but then in other settings, it hasn't really had a widespread adoption. So where do you think things are going for federated learning? Yeah.
Well, the incentives are changing now. So that's where I think federated learning, outside of, I'll say, intelligence and law enforcement kind of things, federated learning, I'll just say, it's been done for over 10, 15, 20 years. But in other settings, you have to have incentive. I think we've had the concepts around doing more federated learning, but you have to have incentive to say, like, if I'm going to be sharing data, is the amount of time I'm going to spend agreeing to a common ontology, which tends to be the first thing you have to do, kind of sorting your ontology, harmonizing ontology between systems, and then all the risks associated, and we have many ways we can control those risks of sharing data. Is that worth it to me? And so we're seeing, though, in some spaces where I see it happening, in the healthcare space, there's a lot of incentive because more data is better for health outcomes, and we're seeing. And you have things like HL7 Fire that, standard ontologies that you can use to say, what does this column mean? When I say weight, what do I mean? Am I kilograms? Am I pounds? Am I stone? What is that value? So there's some environments where we see the incentives, and then there's others where it's more challenging. I think we all thought when we were re-examining like federated learning, hey, the first thing that banks are going to do is want to share information because they want to build better models together to look at like loan requirements and things like that. Well, it turns out banks that kind of information, that proprietary information, it's part of their it's part of their advantage against their competitive advantage. So they might not be as interested. But on the health side, we're seeing it. We see, of course, we see it in law enforcement, intelligence, defense across the NATO organizations, things like that, where again, you don't want to share the details of the data, but you want to share what's important about the weights and the important things from your databases. So yeah, we're definitely seeing an increase in interest, and it's just a matter of like sort of calibrating the interests along with governance and other things like that.
Interesting. So at Flower, we have a unique perspective in that we see a lot of inbound from various organizations and open source development and so forth. And so from what we see a lot of interest in healthcare and finance. And then within those two areas, there's so many sub-areas within those two. They're really sort of a potpourri of topics. Outside of healthcare and finance, you mentioned sort of defense and so forth, law enforcement. Do you see it being rolled out in places like cybersecurity and other sectors?
Yeah, so another area, certainly for, I'll speak on behalf of some of the governments that I talk to, cyber is a huge area where this, and there's been lots of different kinds of sharing. In the U.S. government, I give you a sense, the federal government wants to protect industries, like major industries, core industries. Now, these industries are private companies, right? And so they need information to kind of understand, that sort of that telemetry, what kind of attacks are happening. And it's always been a problem with when you have like a law enforcement and you're asking for data from a company, there's concerns that other things get leaked out with that information. Like, so I don't want you to look at anything else I'm doing. I just want you to look at my cyber information. And so there's special rules that just basically say if they see anything that's not cyber related, they ignore it. So if there was something that looked like a transaction that may be may lead to some kind of law enforcement case, they don't want those kinds of things leak out. So federated learning has been a way to improve where, like, sort of obfuscating more information and just providing the telemetry data, the information that can give us a sense of like signatures of activity, has been a way to bring them back to the fold where they were just like, I gave you too much information and now I got in trouble. I don't want to give you information. So we're seeing cyber being in public sector being a hot topic for federated learning.
Interesting. So we focus a lot on federated and decentralized infrastructure, and you mentioned sort of the data normalization sort of challenge. Is there, outside of that, is there something else you might raise that's a blocker that might be some of the reasons why you see
accurate with my response? Do I know? These are the kind of questions that we don't, a lot of, from a governance perspective, we don't know how to answer in the public sector, particularly I think in commercial world as well. But this becomes an education problem because, and then the other side of that is like the tooling around these systems is like a lot of our tooling in terms of is it working, is it not, is again based on deterministic testing. And we have to, and of course we're all in this business trying to figure that out, like how do we get better testing, how do we get better at understanding what looks good when things start to drift, like do I notice the drift? In the old world of IT, it was very clear. If I was asking you to build me a plane, I would give you, these are the specifications. It needs to be able to fly in the air and handle this amount of force from the air. You're going to go into a wind tunnel. You're going to test that thousands of times, and you're going to come back with answers that are very clear. You're going to keep testing it, and it's super easy and deterministic. AI and how we're using, especially bringing in agents and models that are probabilistic, that it's a range of good. Like what does good look like is a range, not a scalar. So that's probably the biggest problem in the governance. So the governance, it's not that we don't have governance, we just have the wrong governance.
I see. Interesting. Another topic that's quite central to our community, the things that we've been doing, is open source. Flower has been every time we release something, it's very often open source or community led and driven. And so I was kind of curious to sort of like get your thoughts about open source, closed source in this AI world. Is it raising in importance? Is it making it more difficult to make certain things open source because of the way AI can be used? So what are your thoughts on this?
This is a big part of our conversations about data sovereignty. So a lot of things. Two things about open source. First of all, of course, we do everything in the open source community because we know that's where the innovation is. When we think about when OpenAI released their model, a few years ago and started this whole Gen AI, it wasn't until Llama came out that we started seeing the industry jump in and the open source community grinding on that and the real innovation happening. So I can, you've heard our story before, but we believe that's where innovation is. When it comes down to things like sovereignty, you think about things like control, like who owns, who's making the determination of what this model does. Even if in some cases I'm getting an open source model from the internet, there's others had their ideas on how that was going to be trained and what kind of data it was going to be trained on. In a proprietary scenario, you got to worry about if you're using like a service for all of your things, then you're trapped in this place where I don't know when things change. I don't know why they change. I don't know what choices were made. And then I'm potentially building in a very like mission critical system into something that I don't control. And at any point, the price could change. I could get there could be they could turn off my service, and I'm now trapped. So the idea of open source, open models, open standards, bringing that into an environment where you can control that, where you have, that's the primary motivator, I think, around open AI in particular.
Yeah, I wonder do you see a future where, because of the innovation you were just pointing to, that we see open source models continuously outperform closed sourced ones?
So I hear this question a lot, and the first thought is you have to define what outperform means. Okay, yeah. So if you're just like raw compute and you want answers, like it's going to be very difficult for my internal model to outperform if I'm just looking at how fast I can run a frontier model in a very large data system. If you're looking for, can I explain what's happening? What's the explainability of that system? Can I trace back to why decisions were made? If I'm then I would say we're already outperforming with smaller models used correctly. And what you were just showing in terms of networking small models and being able to get to the right model at the right time to do the right thing, that's going to be, I think we're already starting to outperform in that sense. Not to say that there's not needs for frontier models. There's great needs. It's a hybridized sort of model where things that you don't care about sharing out to the world certainly use. APIs can be built to do all these things, but yeah, it's a matter of like outperform is getting an answer and not getting the right answer are two different things. So that's where I think we have to be cautious.
I see. But so if that happens, then the importance of singular organizations that run proprietary models they should diminish over time. Then, if it seems that open source models are able to, broadly in terms of inference, in terms of answering questions, and so forth, able to outperform them, then right now we have a situation where there's a certain few number of companies that are sort of somewhat dominating. Does that mean, by extension, would that mean that we should see AI, the importance of other companies within AI just sort of flatten? A wider set of companies doing better?
Yeah, that's such a hard question. I mean, I think everyone's going to still be, they're still going to be making money and growing influence. But I think, again, it sort of depends on the application. I think right now, here's the one thing I'll say is that a lot of people get very excited when you present what AI can produce to someone who doesn't understand how it works. They're like, oh my gosh, that's so amazing. Like, we can do all the things with that. But when it comes down to things like life and death situations, and you're trying to make a determination of, in a health scenario or a military scenario, these are kinds of things that I think are going to drive that use of models that you can control that are localized versus depending on somebody's incredibly large language model.
That makes sense. I saw you made some comments about compound systems and the rise of moving from single model systems to those that are based on interaction between different models, different types of components. And this is obviously something that is of great interest to the audience. So could you share some of your thoughts about what do you think architecturally is going to change as we go from systems that are largely dominated by a singular model to ones of multiple components?
Yeah, so certainly, I think we've thought a lot about this at Red Hat, and even how we operate internally. The next level, and what you guys just presented, routing is going to be incredibly important. Semantic routing, understanding what a question is, what's the fastest way I can answer that, what's the best way to answer that question. It's going to be multiple smaller models, potentially. Maybe they're all open source. Maybe there's occasionally it's a frontier model with open source model. There's going to be a mesh of these, it's called hybridized AI. That's going to be what we see. But I'll just say, like in the future, though, we're going to run into this interesting case where We're going to go really fast in some places, and in 4 years from now, we're going to have really great, like the thing that's writing my emails and revising documents, and that's all going to be really great. Those kinds of applications that still require a human in the middle to make a decision, an expert, are going to be sort of laggards, and we're going to have to figure out as an industry how we support our customers in those environments with better intelligence back to the human that has to make a decision, so we're not waiting on them. So I see these, these things happening, but again, like we're still limited in some cases by human expert, and for good reason. I don't think we should pull humans out of that. So that's kind of the complexity that I see where kind of models are going.
Interesting. And what's your view on how this works with the rise of agents? So agents are now, you mentioned writing emails for folks, doing various things. Are they ready for prime time as much as they're being pushed in that direction right now? Do we need to take a little step back perhaps and think about where they're being applied a bit more in a circumspect fashion?
You just answered it. So are agents like ready for prime? Are they ready for mission critical use cases? Probably not. Are they? It depends on what you're trying to. It depends on what you're trying to do. Like if for back office activities and like I said, like sort of writing things, create a picture, make this PowerPoint because I hate doing those. They're just going to be better and better, and they're awesome. And agents can go out and collect data from all sorts of places, make my flight, get me on the right flights, those kinds of things. If it's like, should we operate on this person or not? Should we, what medication should this person be taking? And military use cases that involve life and death decisions. Agents, we're not quite there yet. And maybe we shouldn't ever get to that point where agents are making decisions. So I think it's an evolving area, and we're just going to be, again, some things we're ready today.
Sure.
Some things we're not ready today, and I don't think we'll be ready in 5 years.
It was an interesting interaction between the question of the agent and the compound system in which it may sit. So perhaps in certain applications, the agent might be suitable for use if it's in the right environment. Do you think the development of agent harnesses is going to help with this?
Yeah, I think that the way I'd kind of look at this is there'll be cases where you're going to make it goes back to governance decisions. There's times when you're going to want agents to collect data so a human can make a decision. You want agents that are going to do things and they're not going to act. They're going to do things like sort of collecting data. Other times you're going to have them be able to act and perform activities. And you've got to make that determination as you're building the system, how much autonomy you give agents and how much you want to control what they're doing and when you need to inject yourself. And I think that's that'll help. I don't know if that answers the question, but that's kind of how I think about the that incorporating governance into this whole process.
I see. I also, you mentioned looking forward in a few of your answers ago. So on a 3 to 5 year horizon, if you're thinking about AI, and in particular in the public sector, all those sort of use cases and organizations that you work with that actually a lot of us, we don't have a lot of visibility into, I'm really curious if you could tell us, what do you think AI in that domain is likely to evolve to or look like on that timescale?
Yeah, so one of the problems that a lot of governments have is data systems that have been around for 30 and 40 years. So we're not even, in some cases, we're not even talking about relational databases, believe it or not. We're talking about like database and things like this. But just assume you get past the tech debt and those issues. Kind of what I was saying before, I see that in some cases they're going to advance just as fast as commercial organizations. And with those things that I would say are not as mission critical, not as life dependent, and I mean, we couldn't imagine 3 years ago being here, honestly, right? So the pictures will be even better. The videos will be longer than 5 seconds. There's all these things I can say, but then we still have this. I think we're going to have a world where we're going to care about explainability. We're going to care about auditability and these in governments, and there will be restrictions around the use of AI because there has to be. So being able to trace back, understand why decisions are made. And so that will, for those things that are mission critical, they will seem to be lagging. But I feel like that's important. That's like, and the things that we can we don't really care about the answer, those things will just be whatever, 1,000 times better than they are today. So that's you're going to wind up in a world with two very different use cases of AI, and one will look like it's the Stone Ages compared to the other, but for good reason.
Makes sense. Well, thank you, John. It's been a fascinating conversation. You've really opened our eyes, I think, to a lot of domains, like I was saying, that it's hard for us to have visibility on. We know that AI is such an important part of the public sphere, but it's sometimes difficult for us to know firsthand what's really going on. So thank you so much for joining us today.
Sure. Thank you.
Okay, so next we have a panel. We're just going to reconfigure the stage over the next couple of minutes, and then we're going to come back for a panel on Neo Labs, sovereign AI, and a bunch of other sort of related topics. So just bear with us for about 2 minutes as we reconfigure. Okay, here we go. Let's get things underway here. So the next part of the session is actually a nice, juicy, open panel where we're going to tackle all things related to sovereign AI and the arrival of European neolabs. So this is obviously a very wide palette, a wide canvas for people to discuss whatever's on their mind, really. To kind of provide multiple perspectives on this sort of wide landscape of topics, we've got a great collection of folks here on the panel. Let me just introduce them to you. We have, running from left to right, we have Ilya Berkov. He is from Nubius. I met him at an event a few weeks ago, and I learned something I don't not know about Nubius, and that is they run a huge number of the GPUs in Europe and the UK, an astounding number. I believe it might be even the most in the UK? Yeah, so that's incredible. So the amount of infrastructure that these folks are deploying in the European region is just incredible. So thank you for coming. We have Daniel Beutel. You met him, you've seen him just recently. He gave us a great keynote about what Flower is doing next. We have Leo Szczesnik. I'm sorry if I didn't say it right, but he is at an incredible organization called Sprint D. And so these folks here are basically a combination of think tank and funder that really try to incubate transformative ideas all across Europe. And so I haven't met an organization that's better at funding great new ideas. So thank you for joining us, Leo. And finally, we have Lorenzo Sani of Flower Labs. He is one of the key individuals, if not the most key individual behind our Lizzie model. So thank you, Lorenzo, for joining us so he can provide us with some sort of deep technical insights about the topic as well. And I want to jump in there now we've done a bit of an introduction and ask you all this sort of question, which is, given what we've been talking about today, given what we see in the newspapers and where AI is headed, what on earth should Europe do in the next 12 months? So who wants to dive in there and take this one first?
I'm happy to start. Europe should focus on Europe.
Yeah.
We know that a lot of companies have an influence on this. I was at an event yesterday, literally, Demis Hassabis was speaking by Houston. They were asking him about the new book that was released on him and so on. And one of the questions that came up was, why did you decide to do your business in the UK and in Europe, of all places? All of these investors were saying, US is the only place, Silicon Valley is the only place. And he said, well, I finished my PhD in Cambridge. I was curious, everybody said, Harvard, MIT, Stanford, those are the big places to go next. So he said, I went to Boston. I did a postdoc in Harvard and MIT at the same time, because Demis. And he said, I realized that they're good, but the talent we have in Europe is also as good. And he said, that's why I said to the investors and people who wanted to buy DeepMind, I'm happy to do that, but only if we set up a lab in Europe with European talent. And by Europe, I don't mean Europeans. I mean, people from China, from India, from Asia, from Eastern Europe, from everywhere, collected in the European area. And I thought that was very interesting because before DeepMind, there was always hesitation. People thought, if I do something important, by the time I raise a lot of money, I need to go to the US to make it big. And since then, I've seen a big transition into focusing on Europe, developing in Europe, and we're working with companies like Latent Labs and Basecamp Research and innovative companies in drug discovery, drug development, who are all Europe-centric. They have some R&D teams in the US, but a lot of their compute is now being done, and the AI work is being done in Europe. And I see this trend evolving, and I think it's going to just continue to grow.
Interesting. Great start to the panel.
Yeah, I can add on to that. I mean, as Nick said, maybe just a few words. I work for Sprint, the Federal Agency for Breakthrough Innovation. So we are a German government organization who invests in research, and so maybe putting this government perspective into the conversation. I think maybe on the plus side, at least we have achieved the stage of problem realization by now. At least I think 2026, but yeah, we're there, and I think exactly what you said. What we need to do in Europe is we need to allow people who are raised here, who are educated here, or who come here for their education, right? We need to prepare them a fertile ground so that they can actually build here. And there's a couple of components that belong to this. I think there's, of course, the capital situation. So we need to provide actually the amount of money that is required to build these kind of models and to build all this infrastructure. Then there's the regulatory aspect, right? So still setting up a company in Europe is often, it takes time, and you have all these bureaucracy, and we need to improve on that. I think there's also some initiatives on the way, like EU Inc.
I think it's £35 in the UK to register a company.
Yeah, in Germany it's a lot worse. And then there's different legislations over all of Europe, right? We need to unify this. And then there's also the regulation around AI itself, I think. And for us, from a government perspective, I think these are the key areas we have to tackle together with also with compute. And I think this is also where Flower comes into play, right? Actually making compute accessible for people. And I think if we can actually tackle these, then for a young person, for a young researcher who lives in Europe, then it might actually be a viable option to build in Europe and not join some US super lab, essentially. Yeah.
Yeah, so I agree with most things you guys have been saying. I have a different perspective, more related to the life of the researcher. I'm still collaborating with the uni. I have a lot of friends working in university labs. And to me, it's a kind of a waste sometimes, because I see so many people that are super talented and cannot express themselves at their best in Europe or in this context, mostly because of funding or regulations as well. Sometimes they can be pretty annoying. But yeah, I think there's enough resources already to start building these things when it comes to human resources, to talent, to like collaborations, and maybe environment as well. But it feels like there's this tiny bit that is still missing, and maybe it's mostly related to like sourcing compute, for example. If we want to train a massive model, we would need the compute to do that. And
how about 7,000 B300s in London?
Yeah, that
just
will
need to talk to the right people.
Yeah, that's true. Yeah, no. For what I know, like there's a lot of compute like sitting idle in Europe overall. Like one of the research projects I did in the past was trying to tackle this situation. Like whenever like there's compute available, can we tap into it? And Flower was one of the best framework to do these sort of things. So maybe also new methods need to be developed specifically for this European context in order to make these things even easier.
I think my takeaway is, or my biggest piece of advice is for Europe to gain confidence. What I mean by that is gain confidence that AI is possibly the most important wave of technology, and you need to have the confidence as a region like Europe to be able to participate in that. If you don't even have the confidence, then there's just no chance that you can shape this wave of technology. I think it's quite obvious that Europe missed the boat on previous waves of technology. mobile era, for example, is something that was defined by someone else. And I think the most important, again, first step is to gain the confidence to say, yes, we can shape this era of technology. And then with that confidence, you should just go into it and shape it in a way that you think, okay, we're going to find our own way. Because a lot of what I'm seeing is, with a few notable exceptions like Sprint, a lot of what we can see in Europe is basically a copy and paste approach where you say, oh, we're seeing that this model works. We're trying to copy and paste it and try to do the same thing. But then because it's partially government driven, we are going to do it slower and with fewer resources. And it's obvious to anyone that if you do the same thing slower and with fewer resources, you're not going to get ahead. You're only going to fall further and further behind. And so I think the key is start with confidence and then find your own way. And I think we are seeing other examples where other regions, they're finding their own way. And I think Europe could also find its own way that is different from the other examples that we're seeing.
So I want to pick up on that theme and ask you all your views on the issue of what are the fertile areas for Europe to play in and advance in and lead in. And in particular, I think we're most interested in thinking, really at the edge, so really at the frontier of AI. Where should Europe build its superpowers in terms of skills or differentiation? Any views could be application domain, could be techniques, it could be a mixture of hardware and software. But what would anyone's view be on where that's going to emerge?
I mean, I can start. Maybe before I actually answer the question, I just want to say when we talk about sovereignty in Europe, for me, what is important to stress is that sovereignty in itself is actually not a very good goal, right? Because if we just say we want to be sovereign, and nowadays we want to be sovereign everywhere, we want to have our own Microsoft Office, we have sovereign military, we want to have sovereign everything. But what happens oftentimes is that there are two scenarios. Either we are in a global market, right, and you have the sovereign solution, but it's shit and no one uses it, right? B is you actually force people to use your sovereign solution, but that makes you, because it's worse, it makes you less competitive or less productive on a global stage, right? So I think the first thing we have to acknowledge is that we need sovereignty plus technological superiority. I think these have to be fought together. And then I think if we think about, okay, what would be the European approach to achieve this superiority, right, then it becomes obvious that if we just copy the US or the China way, essentially, 5 years later, then we never get to that superiority because we're 5 years behind. So we need to think, okay, what are the unique conditions within Europe that actually could give us an advantage? And I think this, for example, is where what Daniel showed in his keynote before, with all the data that is decentralized lying around across Europe, right? I think this is a huge potential of frontier material in Europe. Also, the amount of compute, I just looked it up before. I think Europe has almost 10 times as many data centers as China, but on a accumulated compute power, it's less than China. So but it's almost on par. So we do have a lot of data centers, and if you combine them, there's also a lot of compute within Europe, but currently we're not in a situation to actually make use of it. So I think if we combine these data treasures together with our compute treasures that are lying around unused, then I think we can build models in all different kinds of domains that are actually competitive on a global stage. Yeah.
I want to add a big +1 to that, because I think it's not a viable strategy to say we want to be almost as good as the number one, or maybe almost as good as the number two these days. If you do something, you should do it, and you should look at it in a way where you say, what is our approach? How can we win? How can we deliver the best solution possible? And I think, just like you were saying, I think there's a lot of industrial data in Europe that could, for example, be used if we find a way. Obviously, I'm biased, but if we find a way to network this together, then I think we could start to create an invaluable resource, a resource that just no one else has. And if you have such a resource, then you can train models no one else has. And these models will be the most competitive models, and it will be very hard for anyone else to compete with these models. And that's basically an approach that can be copy and pasted across different industries. You can do this in manufacturing, but you could also do it in health and life sciences, for example, where if we just get enough hospitals and other organizations together, we can create this massive network. And on top of this network, you can start to create models that no one else can create.
I completely agree. And if you want to look at superpowers, what European innovation is good at is the talent, the innovation, the creativity. What the US system or the North American system is good at is raising capital. We're not going to outcompete the North America on capital raising, so let's not think about that. But the US often use European innovations as a starting point. Let's use the US capital as a funding point for us in Europe. As you were saying, we have so much good data, so many incredible opportunities to actually give access to it. We have so many US companies coming into the UK biobank and various other kind of centralized systems in Europe for the data, for all of this access, for all of this information. Not because they can't do it themselves, but because it's not good enough for what they're trying to do. Why don't we leverage that? Why don't we develop that? And I'm in healthcare and life science, so I'm head of healthcare and life science at this company. I worked in the NHS for 7 years. I saw the innovations that were happening. And, at the same time, there's not much collaboration within Europe. There's a lot of competition between countries. Everybody's looking for a Mistral equivalent of a model that France has. The Spanish are thinking, should we have a French version of Mistral? The UK are thinking, should we have a French version of Mistral? Instead of working together, there's a lot of these kind of internal conflicts. But if we look at it on an industry level, I think that's where we can collaborate and we can do some of this work. And I've seen some pharmaceutical companies who are arch nemesis, working against each other, coming together very nicely, in pandemics, in conflict situations, to work together to achieve these fantastic results. And I think that's what we need to continue doing. And your projects with federalization, I think it's key to give access to wider communities and wider locations to get this done. I love what you're doing.
Yeah, to complement what you guys were saying, which I fully agree with, I think, I agree that most likely sovereignty will start from data, and since we are collecting so much data, even though it's scattered and distributed, that's the starting point we should use. And I really think that one very important missing part to push things forward is collaboration indeed, because I've seen this in many environments. Sometimes there were many talented people with a lot of good resources, but they were struggling to collaborate. And the new innovations, especially from the AI area, are going to come by stitching together methods that have been studied in computer science or machine learning or math or physics to the specific domains where we want the innovation to happen. And this cannot be achieved without good collaboration. And this means sharing resources, data, know-how, facilities, and collaborating more widely than just maybe a department, a lab, a uni.
I think it would be a good idea to open questions to the audience too. We've been touching upon sovereignty and so forth. So if anyone has any specific questions, there's one actually, just a lady in the front here who wants to jump in on this topic first.
Thank you very much. Very interesting. And one question I have is, how do you plan to, because there's so much in Europe, talents, we can have so much to offer. But what I've been seeing over the years is we are not good at all to commercialize what we do and actually to get a business mind. And I've been listening all the talks today. You talk about the innovation, what you are building, but what's next? How you are going to get clients to buy it? How are you going to get the money to make it viable and sustainable as a business? Because it's really where the Americans are much better than us. They are brought up from age of 1, think of making money, try to think how to sell yourself. And I think we are poor, so bad at it, I'm French, British citizen, and I'm not the best on that. But I think we all have this issue because we are not educated. So if we can start, how do you plan actually to switch your mindset to actually be business focused? Because you've got the talent, you've got everything in your power to be successful. But how do you can be brilliant, and you need to generate revenue if you want to be, the best in the market.
Great question. So Nebius started about 2.5 years ago. We started with around $1 billion in capital that we were, raising and putting together. We IPO'd in August 2024. In our first year, we had 400% growth. We raised more money, more capital. We invested all of that money into data centers, into building the infrastructure for Europe. We then built a couple of data centers in the US, for profits, because there's a high demand. And then we started to grow inside of Europe. Now, almost 2.5 years later, our market cap is about 40 billion. That's pretty good growth. We know what we're doing. It's hard. It's difficult. We have investments from Europe, from Asia, from the US, from various locations. But what we're providing is these these data centers for a lot of this work. And if you look at the American hyperscalers that come here, when there was an outage a couple of months ago in a data center in the US, most of the workloads in Europe were down too. And you're like, well, the data's in Europe, isn't it? But it's not. So it's that approach. We have a very specific, unique selling points that we are focused on specific regions. We have these innovations. We're building like crazy, and we're investing like crazy in both in Europe and obviously the US to make some money. We're looking at the innovation in Europe and doing that globally, really. So that's one example of a company that is European by funding. It's European by structure and growing to the wider community of AI. Absolutely, yeah. And we're working with VCs to help the startups to grow. We're working with partners, various enterprise groups and pharmaceutical industries to invest in innovation. We're doing some fantastic work at least in healthcare and life sciences, raising the startup awards. We're doing various initiatives and giving back to the community and giving back to the development. Most of our work is open source. So we do things like Kubernetes and Slurm orchestration tools, but we have our own twist on it where it's 2-in-1 called Operator. That's all open source. You can download it from GitHub. We have these innovations, but we are opening up to the community and to the developers.
I have fairly easy and short response to the question. I think it's a great question. I think we don't even need an answer to that question. It comes back to the point that Leo raised earlier, where if we're aiming to build the best product, if we're aiming to train the best model, once we have the best model and the best product, we don't need to do a lot of planning. There will be demand for that, and that's why we should aim to be really at the forefront.
I think we had a question back there.
Okay, first off, a little provocation. I think we need to consider that there are better alternatives to venture capital as a model for financing our ventures in Europe. So that's the initial provocation. The main point here is that in Europe, there are two key sets of actors, the policymakers and the AI innovators. And there are two key principles at play here: protection and collaboration. So I just want to frame this. We have policymakers in the UK government, who've given the likes of Palantir access to British health data. We cannot have this sort of thing happen in Europe. So we need to address how we're going to deal with those sort of issues and cut them off.
What's the question?
Why are we allowing American actors direct access to critical European unique data?
I guess I just want to jump in. One thought on this topic is that I think it would be useful if we see smoother procurement processes in Europe, so that when Europe needs to get certain kinds of AI, if an AI can be provided by a European company, and it is the best, as Daniel was saying, then the choice should be logical. I think sometimes the pathways are a bit noisier for the local folks and a bit too streamlined for the other ones. That's one, but perhaps there'd be some other thoughts on this topic too.
I think it comes down to exactly the same point that we had before. I think it's not, one question is about allowing or not, but if this happens, then you can see that there is demand for a product. And so why is there no better alternative to pick? And so we should, I think, instead of regulating more and more and complicating the life of entrepreneurs more and more, I think we should actually just accelerate and try to build a better product. And then the demand for that will be automatically there.
Maybe one more thing I can add is also from the government side. I mean, what you describe, it's just like the final symptom of the patient shortly before he dies, right? I mean, the underlying thing is, why don't we have our own Palantir, right? And
Faculty AI in the UK is kind of competing with them?
Yeah, but I mean, this is just one example. I mean, there are many other examples, right? And I think, for example, if you said you need an alternative to venture capital, I think, yeah, we need to change a lot of things in Europe. And one thing, for example, is that governments, but also large companies that we have in Europe, which exist for like many years already, they need to be also more bolder to actually contract startups, and the government has to be innovative with how they procure new technology, right? There is like procurement possibilities actually where government can buy a solution before it even exists. So a startup already knows they get the money once they've developed the solution. So I think there's plenty of options out there, and I think it's not one or the other, right? Everything has to come together. Also, the founders, I think, have to be, or the researchers in Europe, there also has to happen a mind shift that they actually go out and spin off these companies, and not stick only to their labs. So I think everyone has to do their part there.
Absolutely. And I guess looking also at depending on these companies to come in to invest in us, you probably all read in the news recently about the Stargate initiative and the lack thereof in the UK anymore. You've all been at King's Cross. You've seen that beautiful building, or beautiful, I say, that's being built. That was supposed to be a big pharma company from the US coming in. Everybody's just pulled out. And are we looking at having a dependency on these finances to create innovation? No, we should think about what we can do ourselves and continue doing that. Not depend on these companies from elsewhere coming in to promise investing when they're not guaranteeing this investment.
I think there's a question right in the back corner. Oh, sorry, there's one right here. Okay.
Is it on? Okay. Yeah. Thank you so much, great panel members, for the great discussions. Let me take this from another angle. Maybe we didn't discuss it so far. So technology behind AI, infrastructure behind AI, and decision making are very important. But there's something also impact the minds behind AI. So in the US, we're seeing this wave of talent acquisition. We saw, just like football, that they are paying millions to those minds to sign. What is Europe policy to keep attracting those great minds to fuel these technologies. On the contrary, I can see that there are policies, immigration policies, or things like that in the other side. So this would be question number one. And maybe to Dan and Nick, Flower has stands from a startup to a great company that leads this field. For those who have a startup or spin-off from a university, if you get back in time, what is the piece of advice that you can give for someone who is doing startup spin-off in Europe? Thank you.
I can take the first question, and I think Europe doesn't actually need a policy around talent. I think there is an incredible talent pool in Europe already, and any region, this answer is not specific to Europe, but any region benefits a lot from having successful and growing companies. And so if you have successful and growing companies, and if you get out of their way and let them really grow, then even if there is a massive talent wars, and even if you see massive salaries being paid for individual researchers, then if you have these companies, they can participate, and maybe they can outcompete no matter who. So I think the way out of this situation is, again, I feel like I'm saying this for the third time almost, is not to regulate further, but it's actually to unlock and unleash the market and accelerate out of the situation.
2 quick points on your first question. First of all, yes, they pay more, but then they can lay off 1,000, 10,000 people in one day in the US from these giant companies. And then second of all, about talent and money, you probably all read about Jan LeCun, went from Meta, probably a very high salary, came back to the UK, to Europe. He was in France doing some interesting things. There's lots of spin-outs out of DeepMind. There's lots of spin-outs out of all of these innovative companies. I think the tide is changing. It's not all doom and gloom. I think we are getting to that salary bracket. Obviously, it's difficult because we have different finances, but we're getting there, I think.
I think we need to wind down the panel. So if anyone wants to make any final remarks on this. Okay. Well, thank you all for joining us today. It's been a great chat about NeoLabs, sovereignty, the competitiveness of Europe. And so thank you for joining us. Really appreciate it. And so while we just reconfigure the stage, I can start to introduce our next speaker. He is actually joining us remotely from the US. So it's my pleasure to introduce Jerry Watkins. He works at Sandia National Labs. His work and our collaboration, his collaboration with Flower Labs was mentioned during the keynote by Daniel. And so we've been working with him for quite a while now, investigating how we can build better and better software that will enable him to train very large LLMs by connecting the compute resources of Sandia National Labs with other national labs in the US. So Jerry, can you hear us?
Yeah, I can hear you now.
Great, we can hear you loud and clear. I'm sorry that you can't see the room, but we can see your slides, we can hear you, we can see you. So the floor is yours.
Perfect, thanks, appreciate it. Yeah, thanks a lot for inviting me. I've seen a lot of great talks so far, so really appreciate the opportunity to talk a little bit about the project that I've been working on and what we're doing so far. So I'm going to focus primarily on the model training in this project. There's a small team at Sandia that's working on this, but it's part of a larger team. So you could just take the people that you see on the screen, probably multiply it by 6 or so, and that's the broader team focusing on training across the other labs. But we've primarily been the people focusing on the federated portion, which is to try to get a model that's trained across the 3 labs. And I'll talk a little bit about that. So here's a brief outline of what I'll be talking about, and just talk a little bit about myself, my background, just to get a general idea of where I'm coming from. I'll give a brief project overview, some highlights, and then a lot of the next steps that we want to accomplish in the future. So this is a little bit about myself. My background's in computational science, so I develop large physics models. A lot of my research activities revolves around heterogeneous computing on exascale systems. I got my bachelor's at UC Davis in aerospace and mechanical engineering. I went to Stanford for aeronautics and astronautics, working on high-order discretizations and solvers to solve nonlinear partial differential equations, specifically for aero models. Like I went a little fast. And then I've been at Sandia for about 10 years now, and I work on a variety of different projects there, focusing on hypersonics, Earth system modeling, and what I'm talking about today is federated learning, building a large language model towards the US DOE Genesis platform. So here's a bit of motivation. So for those who don't know what the TriLab is, I'm talking specifically about the United States Department of Energy NNSA TriLab, and so that includes Sandia National Labs, Lawrence Livermore National Labs, and Los Alamos National Labs. So the main issue for us is that we have a lot of TriLab data sets that are inaccessible to open and proprietary frontier large language models, and so we want to be able to develop a large language model that has access to those data sets. At the same time, our data sets are not easily shared. We have a lot of internal documents, and we have safeguards in place such that we don't want to share the data across the labs, but at the same time, we need to be able to collaborate and accomplish mission objectives. So the model that we have naturally applies well to federated learning, and I don't think I need to motivate that in this audience, but so that's the approach that we've been taking. It's been a 2-year project. We started in 2024. We're nearing the end of the pilot program for this. And the main impact we've been able to achieve is that we've been able to construct an LLM that's specialized on our TriLab data sets for R&D. We've split up this project into these 3 main thrusts of generating the data, training the data, and evaluating our model. And so, again, I'll be focusing on training, but we've actually hit a lot of milestones across those three aspects of our project. So in data, we've spent a lot of time generating AI training ready data and infrastructure among the TriLabs. So a lot of that work was accomplished through this project. For training, we removed a lot of the technical hurdles in being able to scale training of these large language models, again, across these 3 facilities, which has a lot of access to very large supercomputers and computational resources. And then the evaluation aspects, we've built a pipeline and workflow for trying to identify what we need from a large language model, and also what we don't want that large language model to leak in terms of data. So the main technical approach when we first started, we looked at 3 of the leading frameworks, NVIDIA NVFlare, Flower, and AppFL. So early on in 2024, we realized that this was not a production-ready capability to be able to train these large language models. And so we worked with these 3 frameworks to identify issues and try to push those boundaries to make sure that we can actually do the training of these large language models. For our background, or for our backend in terms of model training, we looked at a variety of different backends, and we decided to go with TorchTitan. Although we are fairly agnostic to the model training that happens across the labs, we wanted something to start with, something that was portable to both NVIDIA and AMD GPUs, and TorchTitan seemed like a good fit for that. They had a paper at the time released where they show that they were able to scale their training up to the 405B Llama 3 model on up to 512 nodes. And so it seemed like a good fit. As a brief outline of our technical approach, right now what we're doing across the 3 labs. So we have machines, both NVIDIA and AMD GPU machines across the lab. We have a main server here at Sandia that launches the jobs. The clients run on the login nodes of our clusters. And on those login nodes, we submit job scripts to be able to do the training on our compute nodes of our compute resources. So right now, in terms of current capability, we're able to train the Llama 3 series. We have been able to train Llama 4, GPT-OSS, and Nemo, and just recently Nemotron 3 Nano. In terms of the construction of federated models, we've been able to construct a tuned 1B and 8B instruct model. Right now, in terms of methods, we've focused on continued pre-training, so just learning next word prediction across all of our documents and generated Q&A pairs across the labs. And our current infrastructure, we're able to do this training on both NVIDIA and AMD GPUs. Some of the highlights for our training process, we've been able to approach 1 million tokens per second with the Llama 8B model in terms of training performance. We have a 16 node configuration to train the 7dB model locally, but we haven't been able to produce the full federated 7dB model across the 3 trilabs yet. We've seen some modest gains in terms of the improvements, at least on a benchmark archive data set. But as we move to data sets that the models haven't seen before, we hope that number improves. We've also been improving our model training process along the way. And we've also, in terms of gauging the amount of time this takes, we've been able to train these federated models. It takes like on the order of 1 to 2 days and that's on the order of 1 billion tokens that we're training. But the real benefit from being able to train federated is that we're able to scale that training process. So we're not limited by the compute power of just one machine. We can actually use all of the resources and use data parallelism in the training process to be able to train much, much more data across all our compute resources. A little bit about our collaboration. So our main goal is to train a 7dB model and to get that in a production workflow such that we can produce them in an efficient way. We also are looking to improve our differential privacy capabilities within the large language model. Some of the main performance bottlenecks that we've seen getting to the 7dB model has been the client memory footprint across the three labs. And also the model transfer performance is a huge bottleneck in moving that 7dB model across the 3 labs. Some early results are on the right where Patrick Foley has implemented a layer-wise communication technique such that we can transfer chunks at a time. And you can see the latency is a huge bottleneck in transferring across these 3 laboratories, which are located in different locations across the US. But we've been able to demonstrate that we can do the communication process. And right now we're trying to improve that communication process, that transfer of the model, and also the training workflow such that it's all in sync and we can improve the performance and throughput of training that large model. In terms of next steps, so I mentioned that a lot of this has been focused on what we can actually achieve in terms of differential privacy. So I think in the next couple months, we'll be focusing on that, evaluating what our large language model is memorizing. I mentioned that the training process can be improved quite a bit. And so we have done some research studies on what improves that training process, and reinforcement learning is one of those techniques where we can integrate the evaluation process within our training to improve that model. We're also looking at new architectures. So we're partnering with Cerberus on that to see whether we can get some of our Cerberus architectures to be included within the training. As I mentioned, my background's in computational science, so we're not just looking at next word prediction, we're also looking at more physics-based downstream tasking. So scaling up a lot of our machine learning models to this quote-unquote foundation model, where we're able to take a lot of the simulation data that we produce across the 3 labs and produce a large model that can identify downstream tasks for our physics simulations. And then we're also looking at new workflows. So a lot of the process that we're building focuses on automation, it focuses on AI agents. And so automating that process automate the process of training is going to be a huge part of what we're doing next. So with that, that's it. Thanks. I appreciate everyone's time.
Yeah, thank you for taking on this monumental effort over there to train such a big model in a federated fashion. We have time for one quick question from the audience, if there is one. Anyone want to ask? Yes, the gentleman just here wants to ask a quick question to Jerry. Oh.
Hello. On the model transfer problem, I would have thought there's established techniques like distributed hash tables and so forth that will be applicable in this context. I know that, for example, Holochain was built to incorporate things like that to address similar challenges. I wonder whether you've evaluated distributed hash tables and whether you've looked at specific implementations like Holochain for that.
Yeah, so we've primarily focused on partnering with a lot of the Federated frameworks. So maybe somebody from Flower can take that, whether that's something that's available in their backend.
It's not currently available. We can consider if it'd make a difference. It might not, but yeah, thank you for the question. Okay, great. Well, thank you, Jerry, for the talk again. Perfect.
All right, appreciate it.
So our final talk before we have a break is from Patrick Foley. So Patrick Foley is going to give you all of the details of a big announcement that we're making today in relation to the support of confidential compute from Flower. So I won't spoil any more of it. I'll just hand over to Patrick.
Thank you very much, Nick, and it's great to see the Flower community here, as so many familiar as well as new faces. I've been on the other side of the talks before from an outside Intel perspective, but I'm now joining from over the last 6 months, and it's good to be talking about some of the things we're doing around confidential compute here today. So my talk is going to be primarily about scaling trust with confidential compute, and specifically what that means in the context of our ecosystem. All right, perfect. Here we go. So you all know what centralized AI is. You have a single group that is typically training a model, but it requires you to send all of your data to where that compute exists. And there's a few issues with this in really sensitive contexts. You may not be able to share that data for privacy reasons or because the data is too large. And in the cases where you can get a waiver to actually share it, that typically comes in the form of a data use agreement that is very hard to come by and doesn't scale particularly well for many institutions at once. And there's also the issue of once you make your data available to a certain party, you somewhat lose control of that data over the long term. And we've seen cases where groups will provide their data, and then it will be made available for training, and then they may lose access to that model at some point in the future. And so collaborative AI, which, I mean, federated AI and distributed AI all fall under this umbrella, really does solve this fundamental issue of letting you control the data that you have and instead send the compute to where your data fundamentally exists. And so inherently, this scales far better than centralized AI ever really can for these privacy-centric issues. But there are certain challenges around federated learning and how you actually scale the trust, which is really the last missing ingredient as part of this. And so this brings me to high assurance collaborative AI. And so my background when I was working at Intel was in the confidential compute side of things, also working on federated learning. And I saw firsthand there the power that confidential computing can have in terms of being able to add additional protections in a federated learning context. So it allows you to disentangle the identity of the person who's training your model from the code that's actually training on your data. So you can trust the code without fundamentally trusting the person who is actually performing the training. It also allows you to protect the model during the course of training. So there can be cases where you might have model IP that you don't want a certain collaborator to be able to see ahead of time. This could be the model weights themselves, but it could also even be the model code definition that you might not want to inherently share, at least at the outset, if you don't have a prior relationship with this person. And then the last piece is that it allows you to verify not just the computer, but also the entirety of the environment where the confidential compute is running. So this brings me to scaling trust. And in some of the early days of federated learning, we saw a number of real-world federations that had a very strong and personable principal investigator who was able to establish a network of collaborators and actually train these large federated learning models across many hospitals worldwide. And this works really great up to a certain point. But then the question becomes harder once you have a new person who wants to join one of these federations. And it's not just about, do they have a relationship with one person in the federation? It's, do they have a relationship with everyone? And this is really where the fundamental problem comes from. And so it's not just one person that needs to sign off and say, yes, I know you, you can be part of this experiment. You have to be able to prove yourself to everyone else. And how you do that is challenging. And this brings me to computational trust instead of relying on personal trust with these trusted execution environments. And this is really what the core of confidential compute is about. So if you don't trust the individual person who claims that they want to join your federation, instead of trusting them, you only trust their environment. And beyond just trusting their exact environment and their ability to spin up these confidential compute trusted execution environments, you can rely on external services called attestation verification services. And these allow you to have a third-party verification that they are running the code that they claim they are actually running, and that it is truly running in a secure way whereas they cannot access it. But there are certain challenges with confidential computing. I've stood on this stage in the past and talked about Intel's perspective around confidential computing and our use of SGX or TDX. And there's multiple different hardware vendors out there. Intel produces one. There's confidential compute from AMD as well as NVIDIA. But the problem is that when you have multiple hardware vendors, you need to be able to verify which one you fundamentally trust and build out your infrastructure to support that. So in the past, it's been homogeneous federations that could be built around confidential computing. But how do you actually work between them is really the fundamental question. And then branching out from just hardware, then you have the consideration of different cloud providers. So if the promise of federated learning is that you are sending compute to where the data is, and many times that can be in a cloud environment. And so you need to be able to support the matrix of both the hardware as well as the cloud. And then the problem gets even more complicated from there, because there are certain services that may be exposed through different cloud environments. You might have different promises that are made for different confidential compute environments. And so there's a lot of intricacy and subtlety to actually deploy these things in a reliable way. And that brings me to something that I'm very excited to be able to talk about here on the stage for the first time, which is that Flower is the world's first heterogeneous confidential compute platform, and we have support for this through SuperGrid. And so, why does heterogeneity fundamentally matter? The main reason is what I alluded to before, which is that there is no vendor lock-in. And what this means is that within a given federation, you can be using Intel confidential computing through TDX. You could have a different data provider that is running their infrastructure on AMD SEV. You could have your data on Azure and run either of these confidential compute environments. Or if you have your data on AWS, that's no problem either. You can bring it as well, and everyone can collaborate together. So what this means is that you can have one federation across many different environments. And this is critical to be able to bring people together in a meaningful way that they can collaborate. And what we see is truly the first time. And this, when we talk about scaling, going from a small number of trusted users to a large number through what has theoretically been possible through confidential computing, now it is possible in a real-world setting in a meaningful way. And so here is what the Flower advantage is. We are truly vendor neutral. And what I mean by that is now that I'm on the Flower side of things, I can say for the first time that our commitment to confidential compute is not driven by our desire to sell confidential computing hardware. We are driven to this because we see the value of it. We've built, my colleague Micah Scheller and I here have built a lot of our careers on the confidential compute promises for these multi-actor collaborative AI scenarios. And we know that these are hard problems to solve, but we are solving them here at Flower. We are aligned with the collaborative AI community. And what I mean by that is because we are truly vendor neutral, we are pursuing these things because it really expands the ecosystem of federated AI and what it can do. So our motivations are totally aligned with what is in the best interest of federated learning. And we also have unparalleled secure federated AI experience. So I've been working on confidential computing in various forms for the last 10 years. Micah is one of the original creators of SGX, which is the first confidential computing platform that was built by Intel. And there is no other group out there, no matter what they say, that has more collective experience than we do here. And we see the problems and we're solving them here at Flower. And so with that, I'll conclude my talk, but confidential compute, I'm happy to announce today, is available for SuperGrid Max in technical preview and will be available for general availability later this year. If you'd like to get early access to this, please sign up for the QR code here, and I'd be happy to answer any questions after the break. Thank you very much.
Hey. Good to see you on the other side. Spicy questions.
Yes.
I don't want some to adversarial, but I've got two mostly. If your customers are happy with using confidential computing in a federated learning setting, because of the threat model of confidential computing, it assumes that they're using it in the cloud, right?
Not necessarily. So I talked about our support for confidential computing in the cloud. We also support confidential computing for on-prem as well. That's another place where this could.
But that's broken.
In what way?
In the way that we know that TDX, for example, I assume you're using TDX or SEV. It's clear, from the white papers and the attacks we've seen, that if someone has physical access to the machine, there's nothing you can guarantee about it. There's plenty of attacks we can conduct. So that's why I'm saying, if it's not run from a public data center that's operated by a third party that has no stake in the computation or the data, then the threat model just collapses. So how do you convince them to move to the cloud if in the first place they want to stay on-premise with Federated?
It's a great question. Are you talking, so Micah I think is jumping to get in here too, but the answer, so are you saying that the threat models are broken from the perspective of the vulnerabilities in confidential computing inherently? So, a number of these, yes, you will see SGX in particular, there's been a number in terms of side channel attacks over the years. These do get addressed through microcode updates periodically. For TDX and AMD SEV, I can't speak quite as concretely to what those look like, but I'm happy to talk through this more after the break. Yeah. Just one more question we can take.
So you talked about you can verify the code that is running. How about data, right? So data with the clients. Is that a solution? Can you somehow put all the data into the enclave and somehow do it, or is it not possible?
I love hearing this question because you're asking the right question, because the code can be verified, data is trickier. It's not impossible, but I didn't talk as much about governance and really how that's intimately connected to confidential computing here. Micah will be giving a talk on that tomorrow. But really, there are some ways that you can deal with it. If you have well-known data sets ahead of time and you can measure what those data sets are, then you can verify those in the enclave, is the short answer. For other types of data sets, there's some subtlety, but we can talk through that. Thanks. Yeah.
Okay, so that wraps up this session. We're going to take a 15-minute break. Thank you, Patrick. Fantastic talk. Thank you, everyone.
Welcome back, everyone. We just heard from Patrick from the team about trusted execution environments and confidential compute. Very exciting topics indeed, and we'll have more talks on that afterwards. I think there's another one coming up which is about trust. This is Tony from Red Hat, who will share his insights and expertise on this. And then tomorrow, as Patrick was referring to, there's also a talk from Micah, one of the Flower members, who will talk more, give more details on what this really entails and how you can use it, and the different parts of it that are interesting for sure. I see that the chat is active, which is always nice to see. I'll try to, I know that we have some people working on the questions. There are questions in the Slack channel as well that you can check out. So if you join our public Slack channel, you can go to the specific channel called Flower AI Summit 2026, and you'll find all the questions there and some answers. We'll continue to answer them over the day as we go on. Before we had Shongshen on the mic and a bunch of people coming through talking about their topics. We'll continue with that. I think we have some speakers and guests coming in here later on as well. But if you have any questions, just feel free to put them in the channel. I'll try to get to them. There have been questions about Lizzie. There's now a blog post up. I think it should be up on the website right now. You can also go to flower.ai/model/Lizzie to see what the latest details are on that end. And now I think we will welcome another speaker into the room. Do we have one? Yes, perfect. Welcome. Hang on. Let's just fix this one, and then you can come through. And then I'm just going to move, and you can stand right here. That's fine. Come closer to the table. That's good. Hi. How are you?
I'm fine. Doing great.
Yes. Feel free to introduce yourself to the audience that are currently online.
Hello, everyone. This is Farzana Kabir. I'm currently working as a postdoctoral researcher at University of Barcelona. And I also have collaboration with Barcelona Supercomputing Center. And together we are working on a project called EUCAIM, which stands for European Federation for Cancer Images, which is funded by the European Commission itself. And before that, I did my PhD from Open University of Catalonia in privacy-preserving data aggregation.
Okay, Very nice. And what is the current state of your project that you're working on right now?
Yeah, the one I am presenting here in this summit is a protocol.
Come a bit closer, sorry.
Yeah, a protocol called Sapphire, which stands for Secure and Privacy Preserving Heterogeneous Prototype-Based Federated Learning. It sounds a little bit complicated because we are trying to combine few strategies together to make the federated learning privacy preserving, and at the same time we are allowing clients to contribute to the learning without sharing their private information, which is very crucial for healthcare data that we are working on.
And what type of specific healthcare data are we talking about here?
Yeah, now as you know, we are working for the UCAIM project. So right now we are working with cancer image data. And yeah, for that it's very crucial because all the clients they need to align with the privacy requirements from the government and such as the GDPR protocol, so they cannot just share raw patient data. Mm-hmm.
And what cancer type are we talking about?
In my protocol right now, I have simulated this protocol using different types of breast cancer dataset.
Yeah, okay.
For multiple clients. And the interesting part is the clients can use any types of training model, and the